Sometimes we want to find a distance, an arc length, but we don't have a nice straight line, so we can't use Pythagoras directly. Suppose I take this interval and I divide it up into n subintervals, and this is, say, x, oh, sorry about that, x of I minus 1, and this is x of I. All right, so I'm going to approximate this part of the curve right here with the hypotenuse. Now, delta s of I is equal to, in this case, the square root of delta x of I plus delta y sub I squared. Okay, just using Pythagoras. Now I'm going to rewrite this. I'm going to factor this delta x of I out. All right, so this will be 1 plus delta y sub I divided by delta x of I squared. Now what happens is I sum all these up, take the limit as partition goes to 0. This gives me the arc length formula that s is equal to the integral from a to b of 1 plus f prime squared dx, and s is the integral from c to d of 1 plus g prime squared dx. Let's try an example where we're proving something we know. Find the arc length of this curve. Well, now I know that the slope is equal to the first derivative. And in this case, the derivative of this is, it's just m. And I know that that is y2 minus y1, sorry about that, x2 minus x1. I really don't know why my computer's doing this. Now, I know s is equal to the integral from x1 to x2, the square root of 1 plus f prime squared dx. So now let me just put that in. This is equal to the integral from x1 to x2, the square root of 1 plus y2 minus y1 divided by x2 minus x1, quantity squared dx. Now this is constant in x, so this is just going to be the square root of 1 plus y2 minus y1 squared divided by x2 minus x1 squared times x2 minus x1. I'm going to get a common denominator here within my radical, so this is the square root of x2 squared plus minus x1, got carried away there. Won't go back, there you go, equals the square root of x2 minus x1 squared plus y2 minus y1 squared divided by the square root of x, 2 minus x1 squared times x2 minus x1, and lo and behold, that is just equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, or what we've been doing with Pythagoras.